What's going on, Algebra? How are we doing? This is our third week of online learning, and I think it's going really, really well for the amount of training that we've had and the amount of training that you all have had. Y'all are doing such a great job, okay? Don't forget that. But it is our third week, and we're hearing more and more about how we're slowly starting to reopen businesses, which maybe means that we're going to be back in school before the end of the year. Who knows? Maybe I'll get to see you before you get to walk, okay? But this week, we are going to be talking about how to, factor quadratics, okay? We talked about this a little bit before, but this is a nice in-depth explanation of everything that you will need to know in order to factor quadratics, okay? And we're also going to be continuing this next week with the quadratic formula, okay? But I fully expect you to watch this video several times just because it's a lot of information thrown at you all at the same time. So, without further ado, here's the video.
All right, Algebra, how are we doing today? Today we are going to be working on solving quadratics by factoring them. Now, last week we worked on solving quadratics by square rooting, and today we're taking the one next step further, okay? So I figured it'd be really important to start back with what a quadratic actually was in its standard form. It's super important that we do not forget about A, B, and C, okay? Each of these pieces are going to be super helpful for us when we are trying to work through factoring, okay? So this process can take a little while and it can definitely take some practice. And I am not expecting perfection from anybody in one of the first times that we did this. We did this before when we were working on that video that I had to do, but I just wanted to come back and make sure that we were having a good understanding. So steps when it comes to factoring. The first step, and this is really always what we should be doing when we're working with equations, we should be looking to see if there's any common factors that we can remove. So for example, if all of our numbers are divisible by 2, it might be beneficial for us to just go ahead and divide everything by 2 and just eliminate that aspect. Okay? After we've removed common factors, then we need to look at what our quadratic actually is telling us. If the coefficient of the x squared term is 1, or if our a is 1, if our a is 1, then this is the function, or this is the form that our answer is going to come into be, okay? So if it's x squared plus bx plus c, or ax squared plus bx plus c, we are ultimately going to have x plus a number times x plus another number, where n and m, and this is the most important part here, where it multiplies to give c and adds to give b. So n times m needs to equal c, and then n plus m needs to give you b. So we're essentially looking for numbers that can multiply to give you the last term, but can also add to give you the middle term b. Okay, and we're going to do a couple of example problems like this. But it's really important because in this last step, if we are trying to ultimately find the actual solutions, it's super important for us not to forget the zero product property. And I have a little review of that right now. The zero product property essentially says that if any individual term that I'm multiplying in my product is 0, then the overall answer is going to be 0. And since I don't know which one is going to be 0, I have to assume that each individual term or each individual factor is going to have to be equal to 0. So in this example, their factors are x and x plus 2. Since I don't know which one is going to be equal to 0, that means I have to assume that each one could be equal to 0 in different situations. So for my first case, I had to say that my first x was equal to 0, or my x plus 2 is equal to 0, and that's where I have to solve for x. So that's where my solutions came to be x equals 0, and then for the other one where it was x plus 2 equals 0, I just subtract by 2 on both sides, and I get x equals -2, and I can show that here as well. -2, -2, again, not perfect, but it's what we have. And that would be my two solutions, okay? So Let's try factoring with an example now. So I have x squared plus 3x minus 4. A little bit different than before. However, I can still see that my x squared term is still 1. My a is 1. So I'm looking for numbers that can multiply to give me negative 4. So I need numbers that multiply be negative 4 and add to be positive 3. Okay, this is really important where I need to know the factors. That is just terrible. I'm going to rewrite that. I need to know the factors of negative 4 here. What can I multiply to be 4? So my factors could be 1 and 4, 2 and 2. And if I need to get negative 4, any one of these could be a negative number. So here's what I'm going to do. If I'm thinking about numbers that can multiply to be negative 4 and add to be positive 3, I know that I'm going to be using 1 and 4. In fact, I'm going to use negative 1 and 4 because if I do negative 1 plus 4, well, that equals positive 3. Okay? So this tells me that these are going to be my two numbers. So I can set it up like this. My two factors, or after I factor this down, it's going to factor down into x minus 1 and x plus 4. Those are going to be my two factors. But now I have to take it that one step further and find the solutions here. I have to do the zero product property. So that means I need to set x minus 1 equal to 0 and x plus 4 equal to 0. And I know that my solutions are either going to be x equals 1 or x equals negative 4. And those are my two solutions when I solved or when I factored this quadratic. Okay, so again, I started off by looking to see what numbers can I multiply to be negative 4, yet also still add to be positive 3. I found those factors, and then I just took it back to this original answer, this original setup of how things were supposed to be, where it's x plus a number, and again, my number had to be negative 1, and then times x plus another number, which in that case, my number was 4. So it was x minus 1 times x plus 4. Let's try another example. X squared minus 10x plus 16 equals 0. So first off, I need to find numbers that multiply to be 16. So I'm going to do the factors of 16. And I know the handwriting isn't great, but it's what we're working with. So 1 and 16. Let's see. 2 and 8. 4 and 4. So let's see here. I also know that all of these could be negative. So I could have negative 1, negative 16, negative 2, negative 8, negative 4, negative 4. Okay, I'll put some commas here. So I'm looking for numbers that multiply to be negative 16 and also add to be negative 10. Well, if I look at all of my factors, I know that negative 1 and negative 16 aren't going to work. I know that negative 4 and negative 4 aren't going to work. So that leaves me with negative 2 and negative 8. Because I know that negative 2 plus negative 8, well, that equals negative 10. So now I have to put this into this form that I was talking about earlier, right here. Right here, just going to box it one more time. X plus a number times x plus another number. So, since both of my numbers are negative, I'm just going to go ahead and make them subtraction signs. So I know that my factors are going to be x minus 2 times x minus 8 equals 0. But now, again, I have to take this into the idea of the zero product property in order for me to find my solutions. And I have to go one step further to say x minus 2 equals 0 or x minus 8 equals 0. So my x's are either x equals 2 or x equals 8. And those are my solutions. Okay, so now I know what a couple of you are probably thinking. Mr. Gerber, what happens if my a is a number? What happens if this very first term is not 1? Say it's like 2 or 6 or 12 or anything like that. Well, we've got some rules for that too. Okay, so going back to our steps here, the first thing that we need to remember, we need to remove common factors if that's possible. That's the very first thing that we have to do. But then, if the coefficient of x squared is not 1, if our a is not 1, so a doesn't equal 1, then use either the guess and check method or factoring by grouping. Okay, now the guess and check method still has some merit, although it's definitely not the method that I would prefer that you use. Okay, for guess and check, I need to list all the factors of the coefficient of our x term or our x squared term or our a. Then I need you to list all the factors of our constant term or c, and then test all the possible binomials you can make from these factors. Again, guessing and checking can lead to some frustration, which is why I suggest that whenever we have a term or our a term is not 1, we go ahead and we factor by grouping. Okay, so similar to what I did in the first one, I need to find the product of a times c. I need to split those two factors, or I need to find the two factors that of a times c that add to give b. And then I need to split the middle term, my b, into those two numbers or into those two factors. And then I group them into two pairs and factor out the common binomial. Okay. Now, again, I know that this is brand new to you, but of course, I've got a couple of examples for you here. Okay. So take some time, write these steps down. Feel free to pause the video. Okay. But we're going to keep moving on. So, what are the factors of 2x squared plus 7x plus 3? Okay, so again, if I'm looking back at my previous term, I need to find the product of a times c. So 2 times 3 gives me 6. Now I need to find the factors of 6 that add to be 7. Okay, so let me shift things around here. So factors of, again, handwriting's pretty bad, but we do what we can do. 2 times 3, and also 1 and 6. Which ones add to be 7? 1 and 6 do. So now here's what I do. This is where it gets to be a little bit different. Okay, I'm going to rewrite my original quadratic using 1 and 6 to be 7. Okay, so I'm going to have 2x squared plus 1x plus 6x plus 3. Okay, so here's what I have to do now. Okay, I need to group these numbers so that way they are a little bit different. Okay, and here is what grouping means in this situation. I'm just going to put some parentheses around different sets of numbers. Okay, so what I'm going to do, let's see here. I am going to rewrite things to be, I am going to rewrite this. I'm going to first shift things over a little bit. So I'm going to do 2x squared plus 6x plus 1x plus 3. And you'll see why in a second. I'm going to throw some parentheses here. Okay. I know that in this first factor, I have common factors of 2 and x. So I'm going to write those on the outside. And I'm left with x plus 3. Because it's like I went in here and divided by 2x for each of these. And I'm left with x plus 3. And in fact, over here, I'm left with 1x plus 3. Well, the only common factor that it has is 1. So, what I have to do now, I have my common binomial of x plus 3 here. So I have to go ahead and take these individual parts and put them together. So I'm going to have 2x plus 1, and then my common binomial, or my common factor, of x plus 3. That is how I'd go about trying to factor that quadratic right there. But of course, I have to take it one step further and try to find my solutions. So I'm going to go ahead and do 2x plus 1 equals 0. That looks like a 7. It's supposed to be a 1. Plus 1 equals 0. Or, what was it? X plus 3 equals 0. So I know that 2x plus 1 equals 0. I need to subtract by 1 on both sides. 2x equals negative 1. Divide by 2, divide by 2. So I know that my x values are going to be x equals negative 1/2 or x equals negative 3. So x equals negative 1/2 or x equals negative 3. Those are my solutions. Okay. One more example here. Okay. I'm going to try to factor 6x squared plus 5x minus 6. So the first thing I need to do is I need to do a times c. So 6 times negative 6, which gives me negative 36. And I need to find factors of 36. Let's just start there. Factors of negative 36, which are going to be 1 and negative 36, or vice versa. It could be, let's see, could be like negative 2 and 18. Could also be negative 4 and 9. Okay, but I'm also looking for the factors that add to be 5. And in this case, those factors are negative 4 and 9. So once I've found these factors of negative 36 that add to be positive 5, that add to be my b term, I then need to take these numbers and substitute them or replace them for 5x. So I'm going to have 6x squared minus 4x plus 9x minus 6. Okay? Now what I'm going to do is I am going to go ahead and I am going to regroup these numbers. Okay, so I'm going to throw some parentheses on them. So I have 6x squared minus 4x and 9x minus 6. I need to look for my common factors for 6x squared and 4x. Well, I know that they for sure share an x, so I know I can divide by that. And they're both even, so I'm going to go ahead and divide by 2. So they're both going to be divided by 2x. So out here, I'm going to have, let's see, 3x minus 2. And then over here, between 9x minus 6, well, their common factor is for sure going to be 3. So dividing by 3 on both sides, and I'm actually left with x minus 2. Whoops, 3x minus 2. I have my common binomial in 3x minus 2, which means that I have successfully grouped these and factored them correctly. And now it's just a matter of rewriting them to be the appropriate numbers. So I'm going to have 2x plus 3 as my first binomial, and then 3x minus 2. So those are my factorings, and now I have to go through the zero product property one more time, okay? So I'm going to have 2x minus 3 equals 0. So add by 3, 2x equals 3, divide by 2, and x equals 3 halves, or it could be 3x minus 2. So 3x equals 2, x equals 2/3. So x equals 3/2, or x equals 2/3. Again, this is a lot of information to try to take in, so I fully expect you to watch this video more than once. But now you need to go ahead and you need to write a comment below saying whether or not what questions you have, if you understand what's going on. And don't forget,